Hello, good evening, good afternoon, good morning, good day, wherever you are in the world, and welcome to the Black Belt Academy of Surgical Skills. My name is David Regan. I'm a professor in the Medical Education Research and Development Unit in the Faculty of Medicine at the University of Malaya. I'm a retired cardiac surgeon. I'd like to thank IECO for hosting the Black Belt Academy and the support of the Academy of Medicine of Malaysia. This is your program, and I do invite people to post comments and ask questions. The only thing I do ask is that since we share a Zoom platform, which enables this interaction, please keep your camera off because I will be demonstrating some models and hopefully some concepts to help the learning. And it does mean with my screen being 2 arms lengths away, I end up as a postage stamp on that screen, and it's difficult to actually see where we are in focus as I demonstrate the models. If this is your first time to the Black Belt Academy, welcome. We're at the beginning of a cycle that's talking about stitching and needles. And if you're returning, thank you very much indeed. We do put a feedback form in the chat room and would be grateful if you could answer it. So we are moving on from our description of the anatomy of the needle. And I'll take you over just to revise that for the moment. So all needles, we said, are made on a circle. And we're not to touch that third, and we're not to touch that third, this way shaped. The working part of the needle is the shaft, which is there. And we have to remember that the shaft is flattened like that. The better enabled to fix the needle in the flat jaws of a needle holder. Because the needle is made in a circle, we need to actually take this through the tissue on a circle, such that if I did a trans-sectional at any point on the circumference described by the needle, I would end up with a perfect circle with the thread in blue sitting in the middle. If I don't carry the needle through the tissue carefully and skid it through either on entry or exit, you end up with this space in green between the thread and the tract made by the needle. And that is the bleed in vascular surgery, and oozing, and the microabscess in a bowel anastomosis, but also predisposes to infection in stitching skin. So to enable us to rotate the needle through the tissue, I've come up with the acronym place, point, rotate. And the place, point, rotate are governed by simple geometry because the fourth part of a circle is 90 degrees. And 90 degrees is the perfect angle, as you have described. In ancient India, 90 degrees was described as a significant angle representing a quarter of a circle, commonly used by them in geometry and astronomy. And the significance of a right angle in geometry lies in its ability to divide a plane into two equal parts, creating congruent and complementary angles. This was described by Euclid, a Greek mathematician and logician considered the father of geometry in 300 BC. He is chiefly known for his Elements treatise, which established the foundations of geometry that largely dominated the field of mathematics until the 19th century. And his system is referred to as Euclidean geometry. It's generally accepted that he spent his career in Alexandria after Plato's students and before Archimedes. And he's accepted as the author of 4 major treatises: The Elements, Optics, Data, and Phenomena. And the Phenomena was a study on spherical astronomy. And his book is divided into 18 propositions, each dealing with important arcs on the celestial sphere. You see, 90 degrees indicates a specific spatial relation and is crucial in mathematical calculations. Additionally, when the measure of an arc is decreased from 90 degrees, it results in what is known as congruent arc, demonstrating the geometric principles at play in relation to angles and their measurements. Now, the practical and symbolic significance of 90 degrees appears in various contexts throughout history. For one, the compass opens to 90 degrees, indicating the balance between the forces of the spirit and matter. 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 equals 90. And according to the Bishop of Langres in 856 AD, this number symbolizes the angels. 90 also corresponds to the Hebrew letter Zade, and in the 18th mystery of the Tarot, or the moon. Masonic rite of Mizraim of Egypt is of 90 ranks, divided into 33 symbolic ranks, 33 philosophical ranks, 11 mystical ranks, and finally 13 Kabbalistic ranks. In Elides, county of Greece, there are 90 senators. In the 6th century, a Latin poet named Orson wrote on the number 3, a poem of 90 verses. 3 times 3 plus 3 times 3 times 3 times 3. Perpendicularity is often used to describe the spatial relationship between 2 lines that form 90 degrees. And it has a number of colloquial terms: right angle or a quarter turn. In terms of numbers, it's interesting that 2 times 3 squared times 5 is 90. 2, 3, and 5 being prime numbers. "90 degrees is formed when 2 lines or segments intersect at right angles. And right angles in any triangle forms a perpendicular triangle, which has unique properties relating to its sides. And we all know a squared plus b squared equals c squared, as described by Pythagoras. But it also formed part of the coordinate systems that we rely on today in maps and global positioning systems. Because the concept of 90 degrees to locate points in any plane using x, y, and even z coordinates. In trigonometry, the unit circle is divided into 4 quadrants by 90-degree angles, aiding calculations of sine, cosine, and tangent. And sine 90 is equal to 1 because at 90 degrees, the y-coordinate is exactly equal to the radius. Cosine of 180 degrees is also 1. Now, 90 degrees is also particularly important in the construction of buildings to ensure stability, structural integrity. For example, when designing a skyscraper, architects incorporate numerous right angles to ensure precise alignment throughout the structure. And by using right angles, symmetry can be achieved, resulting in an aesthetically pleasing design. But it's also used by interior designers to maximize functional space. And they often employ right angles when designing floor plans. The practical application of this, for example, is putting a table up against a wall which allows people to move past but maximizes the area of the table for functional use and arrangement of the chairs. In our increasingly sedentary world, the quest for a comfortable, healthy sitting position has become more important than ever, and prolonged sitting, especially with poor form, can lead to a host of issues: back pain, muscle stiffness, and more serious long-term musculoskeletal degeneration. While there's no one-size-fits-all for this, the frequently cited guideline of 90-90-90 rule is a simple yet effective framework. It dictates that you should be aiming for 90 degrees at your hips, 90 degrees at your knees, and 90 degrees at your ankles, which means that your thighs should be parallel with the floor, your knees bent at 90 degrees, and your feet resting flat. I can't help but think that this is the geometry that is described when I go training with Iaido, the Japanese club in Kuala Lumpur. And all of this reinforces my learnings. Well, the good news is to take your needle and rotate it cleanly through the tissue is all dependent on an alignment of 90 degrees. And I'd like to share with you and do a little test and find out how good you are at picking out 90 degrees. So here we go. And I'm going to ask you to, in the chat room, spot the 90 degrees as we go through. A, B, C, D, E, F, G, H, I. J. So can anybody spot the 90 degrees there? The two 90 degrees in that. Put it in the chat room. You can go back if you wish. J, I, H, L, F, E, D, C, B, A. And actually, if I go through fast, you can quickly spot the 90 degrees. And I believe it's because we're surrounded by 90 degrees. If you look where you're sitting at the present moment in time, the table, the windows, the books, the chairs, they're 90 degrees in every form about you. Now, if I ask you to halve that, would you be able to do that? And I wonder, Dr. Aprajita, do we have any replies in the chat room? Any replies in the chat room? Well, let me go on. Here we go. I'm halving it. See if you can spot the 90 degrees now. Well, 45 degrees. Any ideas? Was that easy or was that difficult? Go back through those. So, in the chat, D, I. Very good. We have a correct answer on F and I for 90 degrees. What about the 45 degrees? Could you spot the 45 degrees in the chat room? Prof. Seeley has said I. Anybody spot the 45 degrees? Well, that was C and I. So the 90-degree alignment we'll come to. It's fourth part of the circle. And it is crucial that our alignment is all at 90 degrees because very simply, we need to make sure it's 90 degrees to the tissue, 90 degrees across what we want to stitch, and 90 degrees into what we want to stitch. Place, point, and then rotate. Simple. One would have thought. Let's then answer the second question that we posed. Where in the upper limb will you see rotation? Which joint? Now, I have with me my skeleton. Here we go. And we'll see that the shoulder is a shallow ball and socket joint, and the glenoid cavity is very shallow. So even though you get internal, external rotation of the shoulder, abduction, adduction, flexion, and extension, the combined movement of that is actually rotation. So if I stand here against my back, I can take my hand in a circle because of my shoulder, like that. Now, some of you have suggested that the wrist offers rotation. Well, let's have a look at that. Extension, flexion, adduction, adduction, and abduction. It's that way around. Ab and ad. Flexion, extension. There's no rotation in that at all. And the rotation of the wrist is a crude combination of movements of extension, flexion, adduction, abduction. And if you look at the wrist bones, there's no possible way that you could rotate those wrist bones. So they're only part of the upper limb that offers you an opportunity to rotate is in fact the forearm. And you know this intrinsically, as we'll describe in a moment. But if you look at the head of the radius, see that head? That head of the radius is round and it sits in a ligament. And that enables this radius to fold over the ulna like that. And it folds. So the pronation and supination are in fact along the axis between the index finger, middle finger, and the common flexor origin. Pronation, supination. And now the everyday object that we use, and you perhaps haven't thought about, is a screwdriver. And while I'm doing that, you need to think to yourself, what are the supinators of the arm? Well, the answer is, what direction do you need to turn the screw to tighten it? And that is clockwise. And that's because the biceps tendon sits, so it enables you to supinate. So the pronation, supination is very much a biceps action, right? Now, we don't want you to be using any force and muscles, but I'm doing this to demonstrate that pronation, supination happens no matter what position I put my arm in. Now, you know that as well, because you have used a screwdriver in the most awkward of places, in flat pack cupboards, machines, washing machines, cars, whatever. So that rotation is important. It does mean, therefore, if we're going to maximize this supination, 90 degrees, pronation, see that? It's 180 degrees. But if I put my fingers through a needle holder, what happens if you look at the end of my needle holder? See, the end of the needle holder is rotating a circle, but if you look at the straw in red, that's pronation, supination. I'm barely getting 180 degrees. and it feels awkward. My wrist is sort of scooping to compensate for this movement. And that scooping, as you would with the wrist like that, and I often see that in stitching, is not a complete circle. As I said, it's a summation of flexion, extension, adduction, abduction, and therefore circumduction. But if I line my needle holder along the axis of rotation of pronation and supination between my middle and index fingers and the common flexor origin where the straw is, I'm now able to rotate the needle. And look at the degree of freedom that I have with this rotation. Not only does the needle remain stable, I have a significant degree of rotation. Not that we're going to be using all that rotation. Far from it, because the delivery and rotation of the needle, as we described last week, is to either separate or cut through the tissue, depending on the point, and you use the curve. And using the curve of the needle means that you don't force it through or drag it out. It's a bit like using the curve, the cutting part of my katana. You let the weight of the katana, which is 1.1 kilos, do the cutting and slicing for you. All you need to do is ensure that you got the position. So the pronation supination is the only part of the arm that we're going to use a rotation, apart from the very shallow lateral cavity that enables us to windmill our arm like a circle. So where else can you get rotation? Well, think about holding a pencil. So if I extend my fingers holding the pencil, now I can actually rotate the pencil between my fingertips. That is a controlled movement of the pencil, as that is the way you would hold a Castelliera or fine needle work. And that's all it requires. It's not much in the way of rotation. But the story now becomes a little more complicated because, and I'll take you over to demonstrate an important point. We'll come back to the needle in a second, but let me just demonstrate this. So if I've got a needle on this rotation, and this is horizontal, and that's at 90 degrees, I can rotate it through. Yeah, that's quite clean. The thing is that 90 degrees only happens if my wrist and elbow are at the same length, and allow me to draw it. So I'm going to draw the needle holder with a needle there, with the elbow there and the wrist there. But if I drop this down, the wrist there is now below my elbow, you'll see that this angle appears. That is not going to be perpendicular to the surface. The needle needs to be angled out. If I draw a line there, and I draw a line there as parallel lines, yep, that angle there is actually that angle there. And the displacement of the wrist from the elbow means that you need to move the needle accordingly, according to the displacement of the wrist from the elbow. So the mathematics of parallel lines dictates the angle as a displacement of the wrist from, and that's 90 degrees there, and that's 90 degrees there. All right? And that's a parallel angle, parallel lines. That angle there is equal to that angle there. So now you can see the mathematical relationship between the elbow, the wrist, elbow and the wrist, and this is here is at depth. Okay, so the thing is, we are operating at depth. And as we said last week, the needles are made on a curve to enable us to operate at depth. So that's 90 degrees, but at this angle here, you can see that is not at 90 degrees. I therefore have to angle it out like that. But I'm not going to roll this all the way along because you can see that wobbles. And in fact, the delivery of a needle through the tissue, as we said, was quarter, half, 3/8, 5/8, but it's iteratively moved cleanly through the tissue. Because if I rotated this like that, it's going to wobble. So the delivery of the needle through the tissue is iterative. So, and to enable you to do that, we need to then think of how we pick up the needle. Right? And the needle pickup is extremely important. We said last week that the pronation, supination, your pickup, it needs to, on the shaft, needs to enable you to rotate the needle back, it says pointing into the tissue. And too often this 1/3, 2/3 dictate. You can see there that the needle is not pointing into the tissue. So the pickup of the needle really has to be such that you can comfortably pronate it back to point. Pronate to point. Now, as I stand up, I need to angle the needle out. And now you can see the needle is 90 degrees to the tissue. I then need to put 90 degrees across the tissue and then point it into the tissue itself. Let's just look at the function of the needle and the needle holder for the moment. The needle holder is around a pivot. So if you think of moments of force times distance equals force times distance around that pivot. The force, the distance is greater there, so I don't have to put much force on this end. On this end, the distance is smaller, and therefore the force between the tips of the needles is greater. That enables me, together with the fact that the inside of this needle holder, and the gold means it's tungsten carbide, is grooved in a diagonal pattern and flat, such that you can pick the needle up on the flat part of the shaft. And if I zoom down on this needle and go as far as we can, you will see that actually in cross-section that is flattened. And all needles around the shaft have a flattened element. And this means that you've got maximum application of the needle to the shaft and the needle driver. Now, the angling out not only enables you to get the 90 degrees there, but it also enables you to do another thing. Just look at this, all right? This flat bit, I'm going to try practice, let go of the needle slightly. See that flat? That's demonstrating the flat. Is that I can hold the needle lightly and then apply the bit more force. And because of the flat, it falls into place. Excuse me, Abraham, would you mind turning your camera off? Because otherwise I end up with a small screen. All right, please could you turn your cameras off? So there you go. I'm demonstrating on a large needle that the flat element of the shaft enables you to pick it up. Now, I only put the ratchet on the needle holder, to be honest, when I'm moving the needle out of the field of view. But within the field of view, I can maintain my control of the needle without the ratchet. And this is important exercise that you need to practice, is can you flip your needle forehand and backhand and pick it up. Note that I'm using the flat surface here to ensure that I haven't got a space between the tip of the needle holder and the shaft. I'm literally using the needle at the tip, and I can position my needle forehand by bringing it in at an angle to the palm of my finger. To do it backhand, I can do this upside down. And now, forehand and backhand. A lot of people say, mount the needle using the forceps. And I can understand this insistence because there's a worry that you might stick yourself with a needle. Well, I'd covered that last week. The incidence is extremely low of picking up hepatitis C. It's 0.0032% over our lifetime. The more important thing is knowing how to safely use your needle. Note that the tip is nowhere near my finger. I'm feeling it with a palp. And the same applies with 7/0s and 8/0 needles, as you often have to reapply. So this ability to flip over forehand and backhand and control the needle enables me to use the needle at will, at depth, without interference of a pair of forceps. So there you go. That's the pickup. 1, 2, 3. 1, just on the halfway, or at a position where you're able to pronate it back and point. 2, it's angled out, and 3, there's no space. Now, let's just have a look at this pointing. And it's interesting, having done a systematic review of needle control, there's only one paper that actually had targets to enable you to point. And the reason to point is twofold. If that is the warp and weft of fabric and you were stitching a buttonhole, you would know that coming in at an angle would be difficult because you're not going through the gaps. It's the same with the tissue. You do need to go 90 degrees. And for those of you who watched the Olympic Games, what was amazing about the Chinese divers, they hit the water perfectly at 90 degrees and there was no splash. And there were many, many examples of that in their diving. The splash is what I call my models. They're splash models, because if you don't go in at 90 degrees or come out at 90 degrees at the curve, there will be a splash. Now, why do we point? The pointing is very, very important. The pointing, if you note, when I was holding my instrument, my index finger was extended down the instrument. And this pointing means that I have extended the instrument and made it part of my finger. That is part of the magic of the brain. Now, look at this, for example. Left red port fingers. Put a needle holder in there. And this has been done in studies with drumsticks and pointing. Your ability and your brain's ability to suddenly make the tip of your needle holder part and parcel of your direction and proprioception is actually quite remarkable. In doing this, try it yourself. The needle holder becomes part of my awareness. And the point also means precision. I'm going to point there, 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 there. And it is exact. And it's the pointing to make the point, excuse me, is part and parcel of the precision and accuracy. So I was thinking to myself, well, how can we actually make this fun and make a point? So I've put some blue tack of varying dimensions down here, and I need to pronate, place pronate point. You see, if I actually do not come down at a perfect angle, I crease this blue tack, okay? But you can see that yourself. You could use a bit of Play-Doh, or whatever, and have a game. So there we go, decreasing sizes. Rotate back, point, place, 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 point. Okay? So you can make that as small as you like, but I'm able to direct the pointing and precision of the beginning of my stitch with accuracy, because it's all an extension of my fingers. So how can we practice this at home and on a mold? And what I have here is a potato. It's microwaved. I do have to put out the obligatory safety alert because microwave potatoes do end up as awfully hot. And if you're not careful, you will burn yourself. Before I put it in the microwave, I actually put lines across the potato. And you note 90 degrees there on the top and 90 degrees here. You'll note 90 degrees to my right-hand side, and you'll note 90 degrees to my left-hand side. This, as a hemispherical object, is best put in a basin to represent the depth at which we're going to operate. So place it 90 degrees across what you want to stitch, but also make sure that you're pressing 90 degrees to the tissue. Rotate it back, and here's a little trick. Place, pronate, point, but actually watch this. As I take it over, see that? You might hear it. I've actually unlocked. And if you look at the needle holder, and let's look at it carefully, you will see that the ratchet of the needle holder has got 1.5 millimeters, if that, ratchet. So with a minimal movement, almost imperceptible movement, I can unlock that. I wish I could draw my iaido as subtly as that, so the sensei can't see me drawing the sword, because that is the secret. The secret to drawing the sword, so the sensei can't see it, is actually to have my elbows by the side. As soon as he sees my elbow move, then he knows that I'm going to be drawing the sword. Whereas the movement is actually in the hands, such that when I turn, and before he knows it, the blade is out. He can do it rather well. Place, point, and now we rotate it. And it's got to come out. Now, the thing about soft tissues, if you look at that, if I'm rotating it cleanly, it should come out 90 degrees to the tissues. Okay? And I need to deliver this carefully out. And note that the delivery is not in one foul swoop. It's iterative. And the secret here also is I take it just beyond the halfway where I picked it up, continue the delivery, and take it out. See, potato skin tore there as I was looking at you in the screen rather than looking at the needle. So 90 degrees place, point it in. You can see how soft this potato is and how fragile the skin is. And take it out and pick it up. As we become practiced at it, rotate it over, no forceps, line it up, place it, and see if you can do it the other way. And the idea is to ensure that you're equidistant from either side, okay? And you're on the line. Again, taking it up, and I apply the ratchet. And you see, in doing that, I have maintained the angle in pickup. The forceps are not involved, and they will destroy your ability to pick up the needle. So as I'm standing here, that angle, just to reinforce again, is that angle there. Now note that when I attempt stitching in the other areas, I need to actually abduct my shoulder and bring my elbow up. But in doing so, my wrist now falls to a similar displacement as my elbow. And in doing so, guess what? That angle has disappeared. So on this side, I need to practice again. Difficult doing these with the camera in place, but this is a common stitch, not equidistant, but I need to continue and note that the delivery of the needle is iterative. Wasn't quite 90 degrees in, I'm trying to get my elbow around. Equidistant is on the line and delivering the needle on the curve. I am using the curve of the needle just beyond the halfway, taking it out, and then I apply the ratchet as it moves from the field. The 5 areas of this potato give me plenty of opportunities to think about the relationship of the wrist and elbow and this angle. That was a dreadful angle around the camera. Take it out, flip it over. And take it through the other way. Now, ideally, this is easier with a smaller needle. I'm using the big needle here, such that I hope gives you a better view. So on the top and away, is the next destination. So I would recommend on the top, away, to the right, to the left, and then towards you. This is the most difficult angle. And in cardiac surgery, that is the angle that I am actually closing the aorta after an aortotomy between the SVC left atrium and right atrium. And it's called the angle of sorrow. Because if you don't get it right, it does bleed. But that getting it right is ensuring that you have the proper angles. For those of you watching, and I know my fellow sensei, Mr. Caddy, will be watching very carefully, but I'm also trying to navigate the camera without obstructing the view. So that I'm not making an excuse, but let me try it with a smaller needle. Pattern. And your delivery is iterative. And what we want you to be able to do is take your needle in and out, flip it over, forehand and backhand on the lines in each of these positions. Oopsie. No forceps involved. Place, point, and rotate. See, I lost the needle control there as I'm rotating through. And I'm actually finding as I'm got my elbow in the air here, doing these repeated stitching around the side. As I explained in the beginning, as soon as the scapula, the shoulder abducts, the scapula moves around the chest wall, and you've got 17 muscles employed. So keeping your arms up for a prolonged period of time does actually become rather uncomfortable. So I wouldn't actually do this repeatedly, because I think you'll find, as I am finding at the moment, elbow in the air is uncomfortable. But you can see the potato with that, it tears very easily. And this is why I call it my splash mode. Because if I don't go in and out properly, I will tear potato, and you get the white of the potato and a splash. Simple exercises, but actually they're testing a lot of elements of your stitching skill. Testing your alignment, testing your needle control, and testing the way you use your needle. Ultimately, as we said last week, to get your needle to move gently and flip from forehand to backhand within the field of view and have control of it all the time will help you tremendously, because as you're operating, your focus is within a 3 to 4 centimeter diameter area. And if you can keep your focus there and stitch and not have to worry about your needle coming out of the field of view for you to reposition it, re-angle it, then you're going to reduce the unnecessary wasted movements and shorten the diastolic interval. And without much effort, not only does your operation become smooth and effective, but you're not wasting any time. So we have come to the end of our discussion about needles, pickup, and angles. And I hope I've given you some idea of how you can practice your skills. And with that, I'd like to ask my fellow senseis, Kari and Chile, to join the conversation and make observations. Whether it's a big needle or small needle, and I was demonstrating with an extra big needle this evening, the same applies. We will look at my splash models in further detail, but for the 7 O's, 6 O's, and even 5 O's, the 5 O we use a banana. For 6 O's and 7 O's, I make a little arteriotomy in the membrane of the yolk of a poached egg. Then you take the needle in and out of that membrane without scrambling the egg. Lightness of touch. But the other thing is the same exercises of pirouetting the needle, picking it up, and seeing the needle flip into position applies on small needles and big needles as well. And it all comes to appreciating the touch. And that is a small needle movement. On a 3/8 needle of that size, you don't need much in the way of movement to get the needle through the tissue, compared to the gross movement that I needed this evening to get the sternal wire through the tissue. Sensei Kadu, your thoughts and observations, sir?
First of all, bravo, once again, masterclass. What you're concentrating on are the basics. So when you start with students, they just want to get on and stitch. But you're slowing it down, and it's important about mounting the needle and then being able to pirouette the needle on the tip of your needle holder. So the demonstration on the back of your hand of pirouetting it backwards and forwards, they need to master that before they can move on. And they
I
all,
wouldn't do it on the back of your hands. I don't want to be responsible for personal injuries.
well,
But,
but
that's
it
the
would,
same as doing Yanko. I don't use a Shikaman blade because I'm not experienced enough yet.
yeah.
So I use a blunt blade. But the sensei in the Japan club have got very sharp blades, and their control is just fantastic.
So once again, it's about deconstructing the whole process, slowing it down and doing it until they can't get it wrong. And it's very frustrating the first few weeks that you do it because you want to make the needle do what you want to do it, but you have to learn how to do that with the needle holder. And practice, practice, practice until you can't get it wrong. And as you say, it's all about lightness of touch. It's about getting feedback from the needle. So you showed it with the so the other thing I observed was your ability to open and close the needle holder. You need to explain to most people that needle holders are built for right-handed people.
Right.
So they may not find it as easy as you demonstrated it. But if they are left-handed, their CSSD, you can have a left-handed needle holder, but it has to be your needle holder because the general population are right-handed, and that's the way we work with them.
I would say I get asked this question frequently, and we know the secretary of the college was left-handed, and he said, well, he learned to operate with his right hand. Because only 7% of the population are left-handed, and effectively for any one operation, you need 3 sets, one in use, one being sterilized, and one on the shelf as backup. And that's for each type of operation you do. Logistically, economically, I don't think many people would actually indulge in buying left-handed sets for the
No.
occasional surgeon in the hospital.
But the
Fact of life.
trainee needs to be aware that that is a
Yes.
limitation.
And that
And
is a limitation and an apology. But what I do say is that the exercises that we're teaching and the exercises we're showing you to practice, if you are left-handed, apologies, it is one of the discriminations in surgery and the design of instruments, the other being made by male hands, not female hands. But what I'd suggest to you is that you do these exercises with your right hand. It's going to be hard work, but I have no doubt whatsoever that you'll pick them up very quickly. And in the end, you'll have a right hand that works just as well as anybody else, but your left hand will always be better. Is that not a win?
so the other thing is that people at this stage of their career have extreme neuroplasticity, and it's an opportunity for you to practice both with your dominant and your non-dominant hand,
Correct.
so
Correct.
that you can use either in a situation. But it's about setting out with a mindset that you're going to be able to do it both ways.
Correct. Correct. And it is repetition, repetition, repetition. It's demonstrate. There was the eight stages of learning. Demonstrate, then repetition, practice, repetition, 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 all the time. But it's interesting. Having completed a systematic review of the literature, the objective structured assessments of technical skills described by Richard Resnick back in 1997 has been used as the gold standard to measure and assess technical ability. What they forgot, actually, in his paper was a 22-point checklist that had a binary score of yes or no, which included how you hold the instrument, finger down there, 90 degrees to the tissue, and complete rotation 80% of the time. That is objective measure. And it's interesting that only 5 papers that I've found since then have suggested anything like that. And those papers, 3 of them are cardiac and 2 of them are vascular. And there was a basic skills course where on a piece of, oh, dare I say it, suture pad, targets were actually drawn and somebody had to hit the target with a pointed needle. But I hope you appreciated my diminishing circles this evening for pointing, because if you corrected pointing, I should just see a pinprick on these circles. And you could do it yourself with a bit of rolled up dough to practice the pointing. Did you like that one, Mr. Kelly?
I did indeed. The other thing is it highlights what happens to the banana in the middle where it gets mushed. You can see how that happens.
Yeah, we will come on to the banana skill, which we've publicized about. We've written a paper about it, and hopefully we publish soon. But that is the Black Belt Academy's black belt skill. But you can only get to that level if you understand the relative steps along the way. And what's interesting, I had a lovely report from Vlad Morrison, who's a fellow sensei and training plastic surgeon in Romania. And he started martial arts because he joined the Black Belt Academy. And his comment about he just got his green belt, and he just realized that it is practice, 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 and reinforcing the basics. And during his practice, the body position and kokuda which is a reverse stance, and quite a demanding stance in karate, is mastered, and suddenly realized that this applies to the basic stances and the basic application of your limbs to the art. And I see the same practicing with the sword. And the lightness of touch was described by the sensei. This is 1.1 kilo sword. He said, the right hand uses this finger and the left hand uses those 2 fingers. All right? Says that and that. And that's the only two fingers that are applied to the sword to maintain it. And if you've got the sword held properly, it's then stopping against the palm of your hands. And he said, with that, in that hold, when you do a cut, your sword will stop and not bounce at the end. And what the sensei look for is when you do a cut, you want to see a straight cut and no bouncing at the end. Because then you're putting too much force in. You should stop, 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 and not like that. And it's interesting with a 1.1 kilo sword, he's still insisting too much strength, too much force, let the sword do the work for you. And I think that applies very much to the needle. If you're picking it up and holding it properly, it becomes an extension of your fingers. Then you let the needle do the work for them. And then it goes through the tissues cleanly, separates, divides parts depending on the point of the type of needle you pick up. So, any other comments? Prof. Seeley, our fellow sensei, is also on the line, and she's been watching.
Yes, Prof. Yeah. Good evening, Prof. Thank you so much. Yeah. Because that is his amazing mastering skills in then place and point and rotate the needle. It's like it's so much so detailed. Thank you so much. We have a little bit challenging. It's like picking up the needle, especially when we do episiotomy suturing, usually the apex is very, very deep in a vagina, it's like deep apex, and then it is from that the apex usually start bleeding. And we have a very, very poor access with the adjusting the lighting and then we cannot have much for the retraction to see that the area. So, and then the needle is that we used to use this 2O vicryl needle and a thread. So it's like, it is very difficult to, when it's bleeding and narrow access and poor lighting. So in order to get this very first apex stitch, it is very, very challenging. So I think it is not only at the skin suturing or visible superficial suturing that how can we overcome this challenge? Yeah, I want to learn from you. Thank you, Prof.
I think you've summarized it. I remember as a medical student, actually. No, beginning as a medical student, yes, having to close
Yes.
and do an episiotomy repair. And you were just told to get on with it, and nobody actually explained what you've described, that you've got to be beyond the tear to actually to ensure you stop the bleeding. But the placement of the needle and the point, and particularly in a confined space, the curve of the needle is important as well. So understanding the geometry of the needle and being specific about pointing exactly where you want to start and having a clear view of that. And when you go in properly and rotate properly, it will come out properly as well. And go from there.
Especially we have to go 2 centimeters beyond the apex. So and more deeper than the wound, so that we can stop the bleeding from that apex. And that is the most important point for us to get it. Yeah. Again, like Prof. Chris say, the practice and practice and practice. We have to keep doing it in order to handle the challenging. Thank you.
Seeley, you can also inject a vasoconstrictor and you use a headlight that gets the light exactly where you want it. Set yourself up for success. How can
Yes,
you do
Prof.
that?
Yes, Prof. Yeah, that's why I'm thinking about that. We also, obstetrician also need the headlights, like a plastic surgery or.
Indeed.
Yes, Prof. Thank you very much. Yeah, thank
Well,
you.
we need to share these tips and tricks. You need to borrow from Peter to pay Paul, but it's the patient that benefits from it. and you as the surgeon understands the procedure better.
Yeah,
But
thank you very much. Thank you, Prof.
Excellent. Any other questions from our audience? No questions? Well, I hope it's been valuable and look forward to seeing you next week as we take this the next step further and we talk about vectors and alignment. You can see where we are going. We will now move on to our second splash model, which will be the banana. I'd like to thank Ayako and Dr. Apogito for supporting Black Belt Academy and my fellow senseis, Chris and Celia, for their valuable contribution to the conversation. Please spread the word, and we look forward to seeing you next week and other participants as well. Thank you.